In this video, we are going to look at rational exponents, which means an exponent that is a fraction. So we want to write rational exponents in root form. So first we will look at what happens when the numerator is 1, but we have a denominator of some number. In general terms, we'll say it's n. That n, that denominator number, becomes the value of the root that we are taking of that base. So let's do a couple questions to see what this looks like. So here we have 4 to the exponent 1/2. So the base is 4. I'm going to put that in the root sign. And then because the denominator is 2, that means I'm taking the second root, which we call the square root. So I'm taking the square root of 4. Remember what you're doing to take the square root or the root of a number. What you're actually doing, because it's a square root, we want to find a number that we multiply by itself 2 times. That gives me 4. And we know that that is 2. 2 times 2 is 4. So when I evaluate the second root of 4, we know it's simply 2, which is this number and this number. In the second example, I have a base of 16. I'm going to put that in the roots sign, but this time I'm taking the fourth root of 16. So I have to write the 4 there, and I don't say square root anymore, I say the fourth root. And so now what I need to do is I need to find a number that when I multiply it by itself 4 times, I get 16. So that is actually 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is 2. And then the third example, my base is 8, so I'm going to put that in the root sign, but this time I'm taking the cube root because the denominator is 3. So now I need to find a number that when I multiply it by itself 3 times, I get 8. So that's going to be 2 times 2 is 4, times 2 is 8. So again, my answer is 2. So just to note, if I have the third root, I have to write the 3 in the root symbol. If I have the fourth root, I have to write the 4. When I have the square root, I actually don't have to write the 2. If you don't write anything in front of the root, we assume that you're taking the square root because it's our most common root that we take. So now let's look at what happens when you have a number in the denominator other than 1. So we'll call it m. So n is still our denominator, that's still our root, but the m value, the numerator, becomes our exponent. So now let's look at 3 examples using this rule. So question 1, we have 4 to the 3 over 2. So my base is 4. I'm going to put that in the root symbol. I'm taking the square root because the 2 is in the denominator. I'm going to then evaluate that, and then I'll take the cube root of that. So I'm just going to highlight to show where I got those numbers from. That 2 is your square root, and that numerator of 3 is the exponent that you're taking. So we know that the square root of 4 inside the brackets here is 2, because we saw above 2 times 2 is equal to 4. So I'm going to evaluate that. So that inside the brackets is 2. And then I still have to apply that exponent of 3. So that is now 2 times 2 times 2, which is 8. It's always best to find the root before you apply the exponent. You could do it the other way for cubed, which is 64, and then take the square root of 64 to get 8. So it does work, but sometimes the numbers are going to be really big. If you have a bigger base or a bigger exponent, and then you have to apply that and then take the square root, it's just going to be a little bit trickier if the numbers are bigger. So it's always easier to work with smaller numbers. So take the root first and then apply the exponent. So in the second example, the base is 81, the denominator is 4, so I'm taking the fourth root, put that in brackets, and it's to the exponent of 3. Because the denominator is 4, the numerator is 3. So I need to evaluate the fourth root of 81. So I need to find a number that when I multiply it by itself 4 times, I get 81, and that number is 3. 3 times 3 is 9, 3 times 3 is 9, and then 9 times 9 is 81, or you can think of it as 3 times 3 is 9, times 3 is 27, times 3 is 81. So in the brackets, when I evaluate that root, I get 3, and then I'm going to apply that exponent. So I get 3 cubed, so that's 3 times 3 times 3, which is 27. And this last example is a bit good because we have a negative base. It's always a little trickier with negatives. But what we will do is write the negative 8 in the root sign. We're now taking the third root and then having the exponent 4. So just a note, we don't actually have to keep negative 8 inside brackets right now because the square root sign acts as brackets as well, but you can if you would like to. So now we need to find a number that when we multiply it by itself 3 times, I get negative 8. It must be a negative. So negative 2 times negative 2 is positive 4, times negative 2 is negative 8. So the cube root of negative 8 is negative 2 to the exponent 4, which is 16. And to figure that out, we've already kind of done the work here. 3 negative 2's are negative 8. So multiply negative 8 by negative 2, and you get positive 16. And remember, because we have an even exponent here on a negative base, we're going to have a positive answer. If we had an odd exponent on a negative base, we would have a negative answer. So now we're going to look at what happens if your rational exponent is negative. So the first thing you're going to do is deal with that negative exponent by writing this as 1 over your base. And then because the denominator is n, we're then taking the nth root. So let's look at a couple examples. So the first one, we have base of 16 to the negative 1 over 4. So I'm going to write that as 1 over 16 to the 1 over 4. So our negative exponent now becomes positive. So then I'm going to apply the rules of rational exponents, just like we did previously in this video, but now it's all going to happen in the denominator instead of in the numerator. So I'm going to now write this as 1 over base 16, and I'm going to take the fourth root because in the denominator I have a 4, so I'm taking the fourth root. The numerator I have a 1, so really I'm applying exponent 1 on here, which doesn't change it. So then the fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. And finally, we will look at what happens when you have a negative and a rational exponent with a value in the numerator besides 1. So again, m is in the numerator, so that becomes the exponent, and n is in the denominator, and that is the value of the root that you are taking. So question B here, I'm going to find base 49 to the exponent negative 3 over 2. So the first thing I'm going to do is deal with that negative. So I'm going to write that as 1 over 49 to the positive 3 over 2. And then we will rewrite this, so it's 1 over 49. Put that in the root. The denominator of my exponent is 2, and the numerator is not 1, it's 3, so I'm going to have to put all of that brackets and say that is to the exponent of 3. So again, I will just highlight where I get those numbers from. This 2 is here, and this 3 is here. So the square root of 49 is 7, and then I have to apply the exponents. 7 cubed, 7 times 7 is 49, times 7 is 343. So that's equal to 100 and 343. Part C is similar, that I have a negative exponent, a negative rational exponent, but I also have a negative base. But I'm going to deal with this negative exponents. So I will deal with that by writing 1 over negative 27, which I will have in brackets to keep that negative there. And I will change that to positive 2 over 3. So I don't take the reciprocal of my exponents, My exponent stays the same, it just becomes positive instead of negative. And then I'm going to write this as 1 over negative 27 in the root, and I'm taking the cube root of that because that's in the denominator, and the numerator of my exponent is 2. And then the cube root of negative 27 is negative 3, because negative 3 times negative 3 is positive 9, times negative 3 is negative 27. So negative 3 squared is 1 over 9. And finally, you may be asked more involved questions where you are given an expression and you have to write it as a single power and then evaluate. So we will do a couple of those. So here I have base 4. I am dividing my bases, so that means I subtract my exponents. So I want a common denominator, so I'm going to write that as 6 over 2 minus 1/2, which is 4 to the 5 over 2. And then to evaluate that, without a calculator, I'm going to write this as the square root of 4 to the exponent 5. The square root of 4 is 2. 2 to the exponent 5 is 32. So again, we notice that we have two bases that are the same, so we can use our exponent rules from the previous lesson to subtract the exponents using fractions, the rules of fractions. Find a common denominator, write it as a single base, and we notice that it's still a fraction. So now I can change the form. So it's the square root of 4, base 4, and then to the exponent 5. Take the square root first to get 2, and then apply the exponent 5. And then again, in the last one, we can use the same rules of exponents that we looked in the previous lesson to write this as a single base. So we have to add the exponents. So if you notice, you are adding a negative, which means you are actually subtracting. So base 27, you have 1/3, take away 1. You need a common denominator when you're adding and subtracting fractions. I'm going to change 1 over 1 to 3 over 3. And then I'm going to subtract the numerators and keep the denominators the same. So I get base of 27 to the negative 2 over 3. So I notice I have this negative exponent, which I have to deal with. So to do that, I write this as 1 over 27 to the positive 2 over 3. And then I'm going to change the form. 1 over the cube root of 27 to the exponent 2. The cube root of 27 is 3, because 3 times 3 times 3 is 27. And then I'm going to square that. And then 3 squared is 9. So my answer is 1 over 9. Something that you may find useful when working with rational exponents is something called flower power. So if you think of a flower, you have your ground, your soil, the flowers on the top and the roots are at the bottom. So flower rhymes with power. So the top of the fraction, so here the top of the fraction is 2, that is your power, which is the same thing as an exponent. And the bottom of your flower at the bottom is a root. So the number at the bottom here is the value of the root that you're taking of your base. So flower power might help you remember the order of the fraction. What number means what?